You may be familiar with the concept of computer forensics from the TV series Crime Scene Investigation, CSI, and its spin-off, CSI Cyber. Modern computer crime, or cybercrime, includes child pornography, fraud, terrorism, extortion, cyber stalking, money laundering, forgery, and identity theft, among others. For cybercrime investigations, detectives rely heavily on digital evidences, such as suspect's GPS data, smartphone data, and computer network data. The ultimate goal of a forensic investigation is to identify, analyze, reconstruct past events or activities, and to present admissible evidence to court. Starting this week, we will study computer forensics concepts along with appropriate procedures and technologies forensics investigator uses to work on digital evidence without tampering with data. The field of computer forensics is relatively young. In 1999, Dan Farmer and White C. Venema, both of them are computer security researchers and programmers, they presented the forensic process in the first computer forensic suite called the Kronos Toolkit, or shortly it's called TCT, which marked the beginning of the computer forensics field. In their presentation, Farmer and Venema defined computer forensics as gathering and analyzing data in a manner as free from distortion or bias as possible to reconstruct data or what has happened in the past on a system. Now it's kind of long, but actually it means computer forensic investigators use forensic tools and follow appropriate procedures to collect, preserve, analyze, and report admissible evidence to court, providing his or her critical judgments of exactly what has happened. The term preserve here means to authorize that evidence presented to court has never been modified. This is crucially important. Following forensic procedure and using appropriate tools are important. The digital evidence could be tainted depending on how it was collected and analyzed, and where it was stored. Also, if you copy a file using, for example, the Linux Unix command, cp, you modify the file's access time, which accidentally taints the evidence. Let's look at types of computer forensics technology. When reconstructing evidence, the first question is, where do we extract or collect evidence from? The evidence may reside in computer systems, computer networks, computer medium, computer peripherals, basically everywhere. Data can be in one of the three states: at rest, which means stored in a computer drives, the cloud, or a USB drive, etc., or mobile phone. Data in use, which means data is in a computer's memory, currently in use, or data in transit, which means moving through a network. The forensic tools that collect and analyze data at rest are different from the tools targeting to data in transit. So, based on that, we can categorize computer forensics by technologies working with different types of evidence. System forensics focus on evidence from volatile data, such as data in memory, and non-volatile data, which reside in hard drives, computer disks, floppy disks, magnetic tapes, zip and JAS disks, log files, etc. Network forensics determines what happened on a system based on network traffic study. such as timeline analysis, IP address, or contents of the packets. This task is technically challenging since this evidence is often transient and does not last as long as stored media. Cloud forensics is an emerging area focusing on cloud-based evidence, such as Google Drives, web-based email stored on servers owned by a third party. This course, however, focuses primarily on computer system forensics, especially for Windows and Linux Unix operating system. While forensics tools and technologies differ from various types of operating systems, the general forensic procedure remains the same. Now we know that computer forensics use technologies to discover information about illegal activities. There are also the counterpart called anti-digital forensics, or ADF, which are technologies designed to thwart discovery of such information.